Example 4, again, now we're going to use our transcendental functions. So the logs, exponentials, and then trigonometric functions are our transcendentals. We haven't done those yet, so let's do one with sine and cosine. Again, you can download that Wolfram CDF player, you can download this file and see an interactive example of it, or you could simply just go to Desmos and graph it to see what it looks like to verify your answer. You can even go into the e-text to see the graph. This one does look pretty crazy. I will let you know about that right now when you look at the graph of it. But let's go ahead and try to find the maximums and minimums without using any graphical utilities, technology, or help. So first step again. What's the first step always? Well, first step, I guess, really, truly, is think about this function, sine of x minus cosine of 2x on the interval 0 to 2 pi. Well, you remember that sine of x is continuous, cosine of x is continuous, so both of these functions together are continuous on a closed interval. Because it's a continuous function and it's a closed interval, we are able to do this technique. The first step of the technique is find those critical values. Find those critical values. The critical values are where the derivative is equal to 0 or undefined. So let's take a look at it. What's the derivative of 2 sine x minus cosine of 2x? Well, the derivative of 2 sine x would be 2 cosine of x. And the derivative of negative cosine of 2x, we're going to have to use the chain rule here. The derivative of cosine is negative sine. So when we're subtracting a negative, it's going to become positive sine. Keep the inside the same, but then remember you have to multiply times the derivative of the inside for the chain rule, which would be a 2, right? So I'm getting 2 cosine of x plus 2, because the derivative of 2x is just 2 sine of 2x. So what can we do with that one? Well, this isn't too easy. This one likely wouldn't be on a test because what's required is if you go back to the trigonometric review, a double angle substitution. Double angle substitution. So what do I want you to recall? I want you to recall the double angle substitution that sine of 2x is the exact same thing as 2 cosine x sine x. That was called the double angle identity for trig. So you need to use that. Why do you need to use that? Because that's what we're going to substitute back into what we just did right here. So when we do this, and why did we want to do that? We wanted to try to get it in terms of one trig function. It didn't quite work, but we needed to change it out. So this would be 2 cosine of x plus 2 times 2 cosine x sine x. We can clean that up a little bit. So that would be 2 cosine x plus 4 cosine x sine x. Again, this is our derivative function, right? So what can we do with that? Well, it looks like both of them have a 2 in common and they both have a cosine of x in common. So let's go ahead and factor that. If we factor a 2 cosine of x out, 2 cosine x divided by 2 cosine x is a 1. 4 cosine x sine x divided by 2 cosine x would be plus 2 sine of x. So that's our derivative function, and again, we want our derivative equal to 0 or undefined. Well, this is continuous, so it's never undefined. So I don't need to check that, but I do need to set it equal to 0. So when I set that derivative equal to 0 to find those critical values, I have to set each factor equal to 0. So let's think about 2 cosine x equal to 0. Divide both sides by 2, and I'd have, where is cosine of x equal to 0? So cosine is your x values. Think about that unit circle. Your x values are 0 at the top of the circle and at the bottom of the circle. So that'd be pi over 2 and 3 pi over 2. Let's look at 1 plus 2 sine of x equals 0. Subtract 1 from both sides, you'd have 2 sine of x equals negative 1. Divide both sides by 2, and you'd have sine of x equals negative 1/2. Again, we're thinking about our unit circle here. We're thinking about when is sine, which is the y value, negative 1/2. Remember, this would be the smaller, negative 1/2 is the smaller of them. So that means I'm closer to the x-axis. Has to be my y value has to be negative, so I'm in quadrants 3 and 4, closer to the x-axis. So I believe that would be 7 pi over 6 and also 11 pi over 6. So those are my critical values. I have pi over 2, 3 pi over 2, 7 pi over 6, and 11 pi over 6. Again, all we did was solve trigonometric equations. There truly was only one step of calculus in this problem. Then it was a trig replacement and solving trig equations from there on out, which we reviewed at the beginning of the semester. Okay. So what do I do now? Let's consider that interval. We have 0, we have 2 pi. What else do we have? Well, we have to put the critical values in here. There's pi over 2. There's 3 pi over 2. We also have 7 pi over 6, which is just more than halfway. And 11 pi over 6, which is really close to the end. So it seems to me that we have 1, 2, 3, 4, 5, 6 different numbers that we have to plug in, including the critical values and the endpoints. Again, where am I plugging these in? I always plug them in for maximums and minimums, in this case, to the original function, 2 sine of x minus cosine of 2x. I'm plugging in 0, pi over 2, 7 pi over 6, 3 pi over 2, 11 pi over 6, and 2 pi. How do I do this? I'm going to go into my calculator. I'm going to make sure your calculator's in radian mode. Your calculator has to be in radian mode. I'm going to hit table. I'm going to clear it out. I'm going to type in 2 sine of x. Close my parentheses. Now I'm going to do minus cosine of 2x and close the parentheses and hit enter. Step doesn't matter, start doesn't matter, ask x is what I need. I'm going to start typing in 0 and hit enter, and I get a negative 1. I'm going to type in pi divided by 2, enter, and I get a 3. 7 pi divided by 6, enter, and I get a negative 3/2, or a negative 1.5. I'm going to type in 3 pi divided by 2. I'm getting a y value of negative 1. I'm going to type in 11 pi divided by 6. Enter. I get a y value of negative 3/2, which is negative 1.5 again. And I type in 2 pi. Enter. And I get a y value of negative 1. So I'm going to go ahead and I'm going to look through this again. I'm looking at my y values. I'm saying which is the highest and which is the lowest. It seems that the highest to me occurs at pi over 2 with a y value of 3. So that's going to be my maximum, pi over 2, 3. And then if I look at the minimum, I'm looking for the lowest y value. It actually looks like we have 2 points that are the minimums. So these 2 points are going to be my minimums. Those 2 points being 7 pi over 6. Negative 1, and also 11 pi over 6, negative 1. So both of those would be my minimums. So I have my maximum, and I have my 2 minimums, and it is okay to have more than one minimum. You can have as many minimums as you want. Here's a nice example with 2 of them for us. Okay, so hopefully you understand the process of finding extrema of continuous functions on closed intervals. Find the critical values, test all endpoints and all critical values into the original function. The highest y value is the maximum, the lowest y value is the minimum.